Good morning, all. How are you doing? Hope everything is great. I can see the attendance is just 16 students. So it's like almost half the number of students in this section. Okay, now I will finish doing, or we will do it, we will finish doing chapter number 2 today, inshallah. Okay, so we will discuss more examples about record-based and object-based data models. Okay, then we will talk about conceptual data modeling or physical data modeling. Conceptual, then physical. Then we will enter with functions or functionalities of database management systems. Okay, now let's have a recap. Previously, we have discussed the 3 levels. Okay, just to refresh your memory, the 3 levels, ANSI Spark architecture, external, conceptual, and internal level. We said for the external, it's the user views. The conceptual is the logical view or the community view. And the internal level is the physical representation of the database. Then we said we need to have mapping between these levels by having schemas. So we have external conceptual mapping and then conceptual internal mapping, just to make sure that all data in the database will be reflected properly in any of these levels. Okay, so mapping will ensure data consistency and integrity. Okay, this is data map, schema mappings and instances. So external view will be reflecting the conceptual level, whatever the conceptual level, and same conceptual level will be also mapped with the internal level. And then we talked about the data independence. Okay, we discussed the logical data independence and physical data independence. We said any change for the logical data independence, we said it's any change in the internal schema will not be, the logical data independence means any change in the conceptual schema will not affect the external schemas, while physical data independence, any change in the internal schema will not be affecting the conceptual schema. All right, then we talked about DDL and DML. All right, we also discussed the data dictionary or system catalog. Then we talked about the query language, procedural types of DMLs, types of DDLs, types of DMLs, and then the fourth generation language, which is like SQLs, and the applications. Then we went through the data model. We said structural, it includes or contains 3 main parts: structural part, manipulation part, and set of integrity constraints. Then we talked about external data model, conceptual data model, and internal data model. We gave examples here: object-based data model, record-based. Both are for to represent the conceptual and external levels, while physical will be representing data in internal or physical level. Okay, we give examples about object-based, which includes entity attribute relationship, and they are entity relationship, ER diagram, semantic, functional, and object-oriented. Then we talked about record-based, which display data as records, like, for example, relational. Let me just relational, network, and hierarchical. Now we stopped here in the relational, right? We will start here today. Relational data model. So relational data model is a record based, which represent data in the database as records. Okay, so our records, relations or tables. So it's like, as we said, represented as tables. Each table includes number of columns and number of rows and it has a unique name. Like, for example, this relation or these tables, two tables. We have last time or previously you have mentioned the link or the relationship between these two tables. You say that the branch number is the relationship or the link between these two tables, right? Can you remind me, what is the branch number in the first table? What is the branch number in the first table? Anyone? What is the branch number? What we call it? Yes, Mariam, excellent. Primary key. Primary key. So primary key is a branch number in a branch relation or table is the primary key. How about branch number in the second table? Branch number in the second table, we call it, yes, exactly. So foreign key. Excellent. Okay, so this will ensure an association between two relations. So this is relational reconnecting. So what we were saying, we said that relational data model is a record-based data model which provide information or represent information or data in the database as relations. Okay, and it's like relation, we can call it relation. Alternatively, we can call it table. Okay, table. So this will be applied to the logical structure of the database. All right, so it will be applied to the logical structure of the database, and it's the logical structure, which means external and conceptual levels. All right, but it does not apply to the physical structure or the internal level. Okay, so it does not apply to the physical structure. This is what we need to know about this relational data model. Now, the second type of record base is network data model. network, it's a way of representing data in the database as a collection of records. All right, so collection of records, and these records are called nodes or segments. See here in this figure, you can see that every node will be linked to set of other records, or we can call it, and all set can be known as edges. All right, so here is a network data model. See, the way of representing data will be different. Still, it's record based, it's record, but it's not organized as table. It's not a relational data model. It's like collection of records and or nodes or segments, and will be linked to other sets of edges. All right. One common example about this is computer. Just let me check. Here is it's hidden. Let me just check if I will zoom it out. It will not be shown as well. Anyway, so this is another type of record data model, record-based data modeling. And I think my system is stuck. Okay. All right. So one example, a good example of network database management system is Computer Associates IDMS, or I'm gonna write it here. Just a minute. So one good example is this one for the network data model. Okay, I wrote it in the chat. In the chat box, okay? You can see it. So Computer Associates IDMSR. This is an example of the network data model. Okay, the third type is hierarchical, which is still a network. It's a network, but restricted type of network data model. Okay. What is the difference between hierarchical data model and a network data model? It's represented by sets, or like tree data model, because every node, okay, every node has one parent only. All right, I'm going to show you here. This is a hierarchical. It's still a network, but we call it hierarchical because it's restricted type of network data model. And still, it's a collection of records, and it can be represented as nodes and set of edges, or nodes or segments, and set of edges. You can find that every level, or every node will be referring to one parent. Okay, so see, for example, this record will be having only one parent. This is the parent. So this is parent. Okay. And these are nodes. This is the node. This is just an example, okay? This is one example that every node will have, or will be referred to one parent. Okay, so this is about the three types of record-based data model. How about physical data model? How about physical data model? By the way, there is an example here for the hierarchical. Most popular is IBMS IMS. This is the most popular hierarchical database management system, IBM. Okay. How about the physical data models? We talked about external data models. We talked about conceptual data models, which can be represented as object-based and record-based. Object-based, like entity relationship diagram, or other types. But we focused on entity relationship. Record-based, we focus on 3 types: relational, network, and hierarchical. Okay, how about the physical data model? How it can be representing data stored in the database. And this is where we can describe in the physical data model, we can describe how data is stored in the computer or the database by representing any kind of information, like, for example, record structures. We can also describe record orderings, access paths, file storage, size, file sizes. All these things can be represented and described in the physical data model. There are 2 common types of physical data models: unifying model and frame memory. See, it has a link or a connection with storage. Okay, storage space. So let me just write here, representing storage information. Okay, so this is about physical data model. Now, conceptual modeling, or let's talk more about conceptual schema. Okay, you know that a conceptual schema will be representing the main data in the database, or it can be a heart of the database. All right, this conceptual schema will support external views. Okay, it will support external views, and it will be supported by the internal schema. It is supported by the internal schema. So the internal schema is a physical implementation of the conceptual schema. Because we have conceptual schema, then implementing the conceptual schema, okay, and then implementing conceptual schema will be easier because it will be already described, okay, properly. Now, it should be accurate. The conceptual schema should be accurate. There should be clear information and data described, because any missing data will cause incorrect representation or implementation. Okay, so conceptual schema is the heart of the database, and all information and data must be described properly. And any missing piece of information or data will lead to some errors, or let's say missing parts of implementation and representation. Okay, now based on the conceptual schema, there must be conceptual modeling. How we can model or represent data from the conceptual schema. Constructing a model for the conceptual schema must be independent of any implementation details. Like, for example, we should not mention anything about the database management system, what is the application program, what are the programming languages, any other physical consideration like storage space, file path or access path, and so on and so on. So conceptual modeling must be independent of any implementation details. But in the logical model, when we have a data model or a logical data model, we need to consider which targeted database management system will be used. Okay, this is something we need to put in our mind. The last part of this chapter slide will be functionalities or functions of database management system. There are many functions. Let's say, how many? Let me just count them. Here, 10. Let's say 10 functions. Yeah, 10 functions of database management system. So what are functions of database management system? Of course, based on your understanding, okay, previously we mentioned some of these functions, okay, while we were discussing some concepts about database management system. We understand some common or some functionalities already. So let's just focus on these functions. First of all, the main functions is data storage, retrieval, and update. So the database management system is able to store, to retrieve, and update data. All right. So also, we need to know that this mechanism, ability to store, retrieve, and update, will be also integrating an ability to hide some aspect of data from unauthorized users. So for example, by having this mechanism, okay, not all users are able to be aware of the file organization, the file names, the file size, the storage structures, right? So these are all hidden details, because it gives only ability to store, retrieve, and update data to certain users. All right, so this is function number 1: data storage, retrieval, and update. Also, secondly, we have in the database management system, we understood that there will be a user or system catalog. You remember we discussed the DDL, the result of compilation of DDL, the data definition language, will be stored, all details will be stored in a system catalog or metadata or the data dictionary. This is the same. So any description of data items will be stored and accessible by users. For example, it will include number of things like names, types, size of data items, names of relationships, integrity constraints or rules or restrictions, names of authorized users or unauthorized users, data items that can be accessed, okay? And for example, each user can access, and types of access allowed, like for example, is it allowed to insert, is it allowed to update, is it allowed to delete or read access. All right. Also, in addition to that, there will be the schemas, mappings, external, conceptual, and internal schemas mapping between them. All will be stored in the user accessible catalog. Usage statistics, like the transactions, number of accesses, okay? All these can be stored and accessible, can be stored as a catalog, in a catalog, and will be accessible by users. So system catalog is a fundamental component. Why? System catalog is a fundamental component. Why? Because there are so many benefits of having a system catalog. What are the benefits? Why we need to have a system catalog? Because of some reasons. For example, here we can say number one in the system, the main benefit of the system catalog, any information about data, okay, are stored centrally. It's a centralized system, right? So information or description about data will be stored as a source or as a central resource and can be accessible by any user, which helps to maintain control over the data. Okay, so this is number one. So it will be stored. Just okay. So number one will be any information will be stored centrally and help to maintain control over the data. Number two, there will be a definition about data, so it will be meaningful, understandable, and all users will understand the main purpose of this data. Okay, so it will be meaningful and understandable by other users. Number three, also any communication will be simplified because they will understand the meaning of data or the purpose of data. So it will be identified all the definitions of data, identifying. Number four, other benefits of having a system catalog. Number four, also if there is any redundancy or inconsistency, it will be easily identified because the data is centralized, so they will have more control over redundancy and inconsistency. So it will be resolved because it's centralized. They will figure out where will be the redundant data and they will resolve it. Number five, any change can be recorded. Okay. Number six, there will be also if the impact of a change can be determined before it's implemented because it records it. It records all data items, all relationships, and all its users. So any change, and the impact of any change will be noticed before implementation, even before implementation, because everything will be clear and stated and recorded. Number seven, it will provide a level of security. Number eight will provide a level of, sorry about my, let me just, so number eight will be a level of integrity. Okay, number eight. And number nine, auditing will be allowed over the information or can be provided. So these are 9 main reasons or 9 main benefits why we need to have system catalog as a fundamental component of the database management system. Okay, so there are 9 benefits of having a system catalog. The third function of the database management system, so we mentioned 2 functions. Number 1, ability to store, retrieve, and update. Number 2, system catalog or user accessible catalog. Number 3, transaction support. So the database management system, basically, it will support any number of transactions, even it's handled at the same time. Okay, for example, two users are having or are updating records at the same time. So the database management system will have control over multiple transactions by multiple users at the same time. So it will support, for example, it will ensure that the update will be reflected, okay, and in the system or the database. So what is the meaning of transaction? The transaction is any action or series of actions. It's carried out by a single user or application program. So it will accesses or changes the content. Now, for example, a transaction can be adding a new member of staff. It can be updating the salary. It can be deleting property, for example. Okay, so this is a transaction. Any action or series of actions which is handled by or carried out by a single user or an application program. So there will be a change. All right. Sometimes when deleting a member of a staff, also this is a transaction, reassign the property that managed to another, that is managed, or reassign another property to another member of staff. But see, if a transaction fails during execution, like for example, sometimes when a computer crash, okay, the database itself will be in inconsistent state. Okay, when there is any failure in the transaction during the execution. So any change have been made after this, after inconsistent state, it will be like undone. Why? Because the database must be returned to a consistent state first, and then it will perform any other change. So any change, if there is any failure in the transaction, there will be something called inconsistent state for the database. So any changes before that will be undone till the database will be in consistent state. Function number 4, concurrency control. Concurrency control. What is the meaning of concurrency? Concurrency. Anyone can tell? What is the meaning of concurrency? Yeah? Guys, I will focus on the attendance. Okay. Yes, anyone can say anything about concurrency? We mentioned that before. Concurrency, the database management system concurrency control means it's Qasim, sort of, but since the database management system is centralized, okay, so it must support multiple access by multiple users at a time. This is the meaning of concurrency. So there will be control over multiple access, okay, by multiple users. So this is the meaning of okay, yes, Halia, yes, exactly. So more, let me just read it again. 2 or more events or circumstances happening or existing at the same time. Yes, yes. This is something called concurrency control. But in the term database management system concurrency control, I mean that multiple users are allowed to access at the same, or to, let's say, manipulate, insert, delete, or carry out any transaction, any type of transaction at the same time. All right. So this concurrency control services will ensure that everything is changed, will be updated when multiple users are updating concurrently or at the same time. Okay. So it's easy. It's very easy process when all users are just reading data. It's very easy if they are just reading data. But what will happen if 2 or more users are updating at the same time? It will be very hard to ensure the concurrency while two or more users are updating at the same time. So this is the main role of, or this is the main function of database management system. When two or more users are updating at the same time, or handling or carrying out different transactions at the same time, it will have support. It will have concurrency, control, and support. Yes, exactly. Especially if it is the same data. So for example, I will give you an example here. Imagine that we have two transactions, okay, T1 and T2, all right? T1, transaction number 1, will be withdrawing $10, all right? Transaction number 2 will be depositing $100. Okay, imagine that they are done at the same time, exactly the same time. If they were executed serially, the final balance will be how much? If the first balance is $100, for example, read balance, see the first line, the first balance will be $100. Okay, so the balance is 100. If it is done serially, okay, it will be how much the balance would be? 190, right? $190. Why? Because for example, let's assume Qasim, for example, he withdraw $10 and he has $100 as a balance. Okay? From the same account, someone deposit 100 for the same account, deposited $100. So how much will be your balance, Qasim? You withdraw $10. Yeah, I said. Yes, exactly. So you will have $190, right? This is the thing. This is what we need to think about. So the database management system will balance this, or will have control over these transactions. What if these two transactions are done the same time? Okay, if there is no concurrency, control, or balance, there will be something like, see, if this transaction number 1 will withdraw $10, and then it will be 90, right? There will be balance $100. Okay, then it will be the same time 200, right? $200 if someone deposited $100, so $200. When someone withdraw $10, it will take the first balance, which is $100, without updating it to $200, because it's done at the same time. Okay, if there is no control over the concurrency, so there will be $90 only in the balance, because the transaction number 1 will assume that the balance will be 100 only. Transaction number 2 will assume that the balance will be 100 only. Okay, got the point? So transaction number 1 and number 2, if they are for example, carried out together at the same time without any control over the concurrency, there will be missing data, or not updated properly in the system. So there will be $90 only, because assuming that for transaction number 1, assuming that it will take $10 from the 100 and then 90 will remain. Okay, without taking into account that $200 is the new balance. Got the point? So the database management system basically will handle this properly, will provide a mechanism of concurrency control. Is it clear, guys? Is it clear? Or yes or no? Okay. Because in this case, it will overwrite the previous balance. Overwrite it. 90 will be overwritten over the 200. All right, Gina, thank you. Okay, what else? Another function of database management system is recovery services. So there will be a mechanism of recovering any damage caused by for example, caused by system crash, like, for example, media failure. There are so many reasons for damage, right, in the system damage. Hardware or software error, okay, power failure, for example. If the user is detecting an error during a transaction, there will be failure in the transaction during the execution. Okay, so all these are examples of failures or damages. So the database management system will have a recovery service that will return the database back to its recovery, or restore it to a point that there will be no damage. Number 6, authorization services. There will be authorized users and unauthorized users, okay? For example, in the University of Bahrain, students and faculty member, and there are administrators, okay, administrative staff member. So authorize users to display timetables, each student personal information or personal data. These are students and maybe the advisors, right? These are authorized users for displaying or having the view of student information and, for example, all things about students, okay, anything related to students. So only students are authorized to have the access, plus the administrative staff, the admin, and the advisors. Other than that, they are unauthorized users. How about staff information? Who are the authorized users in the University of Bahrain? Are students or authorized users to look at staff salaries, for example? Yes or no? Students, in this case, yeah. In this case, students are unauthorized users, right? So this is the point. Authorization services. The database management system will provide a service that authorizes certain users to get access to particular data and unauthorize others to get access to it. So for example, here we have only branch manager is allowed to see the salary. The main point here is to protect the database from unauthorized access. Exactly. You can only see my name, right? Email, some contact information, and so on. Okay, number 7, support for data communication. Yeah. Data communication means users can connect with other users, okay, and or other users or other applications or application programs. So they can access from different kind of devices. They can use their computers to get access to the database management system, so from their computers, or they can access it through a network remotely. All right. So database management system provide support for data communication as like handled by something we call data communication manager. This is something integrated with the database management system. Okay, data communication manager will allow or will enable users to get or to communicate with others and like sending a request, receiving, for example, a feedback or answer. Okay, so this can be handled by data communication manager. It's not a part of database management system, but it's integrated with it. Okay, another function is integrity services. We know that it's centralized. Database management system is centralized, and there must be services to ensure data integrity or consistency. Let's say it's like the quality of data. Okay, we are talking about the data quality, and it can be expressed by what? Who can tell me? Data integrity can be expressed in terms of what? Here it's mentioned. We mentioned that before. How we can ensure the data integrity and consistency? By applying some rules or some restrictions. We call it something, which is, okay, it's mentioned here already. Constraints. Okay, so data integrity. Once I said, exactly, Qasim. So once I said, put this in your mind. Once I said data integrity can be ensured by what, having what, expressing what, it's constraints. Okay, set of constraints or rules that um, cannot be violated. Okay, so we can say that the database management system has this services of integrity to ensure the consistency, and any change in the data will follow these constraints or rules. Services to promote data independence. Also, data independence. You remember when we said the database management system has this data independence when the definition or description of the data structure is separated from the program code, right? Which will ensure that any change externally will not affect whatever internally and vice versa. So this is data independency. Data independency, okay, will be achieved through a view or user view or subschemas, because anything will not be shown, will not be displayed. Anything change, any change, for example, file structure or storage space details, anything internally will not be displayed to other users in the views, which will ensure that, or which will show that there is a data independency here. Physical data independency is, yes, it will not affect others. Exactly, Qasim. So a physical data independency is easier than a logical data independency or logical data independence because logical is more difficult. Any type of change to the logical structure will be prohibited. So it's easy to add a new attribute or entity or relationship, but it's difficult to remove. Okay, it's difficult to remove. This is about the, sorry, I will take more 2 minutes from your time. The last one will be utility services. This will help the database administrator to handle the database properly. Some utilities will work for the external level, and others will be work for the internal level. Okay. So external level will be can be produced by the database administrator. For example, importing facilities. This is a kind of utility when staff member or for example, flat files will be imported. Monitoring facilities, monitor the database usage, statistical analysis to check the performance or analyze or examine the performance. Index organization facilities, and garbage collection and reallocation. This is by removing deleted records, okay, from the storage space. So there will be more control over any deleted records, any unwanted records. Okay, so that was all for this chapter. Do you have any question? Do you have any question? Okay, by the way, the activities, I have fixed the problem in the link by separating it to 2 links. One true or false activity, and the other one is multiple choice. Okay, I want you to try, go and have them or do them on your own, and then let me know if you have any comment, any feedback next time, inshallah. Okay, thank you so much. Yes, only chapter number 1. You too, have a nice weekend. Thank you for attending today, and sorry for taking 3 more minutes from your time. Thank you. Bye bye.